Jason's satellite's sea surface mapping radar reveals a chain of active volcanoes a 1.5 miles down at the bottom of the Pacific Ocean. This is where that critical interaction between molten rock and freezing water takes place. This footage was taken with a remotely operated submarine, also called Jason. Lava and superheated gases spill out of cracks in the ocean floor, known as hydrothermal vents. Jason reveals what happens when cold ocean water penetrates into the cracks. A magma chamber below heats the water to up to 750 degrees Fahrenheit. In the pressure cooker environment inside the cracks, the dense, salty water actually dissolves the solid rock. Complex chemical reactions take place, producing minerals containing sulfur and iron. These are nutrients that living organisms need to survive. The seawater, now loaded with minerals from inside the Earth, streams out of the hydrothermal vents. These nutrients feed a thriving ecosystem that includes shrimp and exotic creatures like tube worms. The deep ocean currents carry the leftover nutrients away. Over thousands of years, they circulate through the oceans, ultimately rising to the surface and contributing to an amazing explosion of life. And we can see this activity with NASA's Aqua satellite, which is equipped with instruments that observe the Earth in many wavelengths of the electromagnetic spectrum. One tool is called MODIS.
MODIS is pretty much the crown jewel of the Aqua satellite. It's an enormous scanner, so it basically covers the whole world every day.
MODIS scans the ocean in the infrared and the visible portions of the spectrum. It can detect extremely subtle changes in the temperature and color of the water.
So what we have in space is an instrument that looks at very, very small parts of the spectrum. And we measure how much light comes back in each part of the spectrum.
Looking down at the west coast of South America, MODIS detects an upwelling of cold water 150 miles west of Peru. Then it detects a particular shade of green. This identifies the source as chlorophyll, a sign of plant life. It's clear that the satellite has spotted a massive bloom of tiny organisms called phytoplankton. Just below the surface, these phytoplankton are absorbing the rich soup of minerals that have come from the deep ocean. And with light from the sun and carbon from the carbon dioxide in the air, they multiply by the billions. As MODIS shows, the plankton multiplies so quickly that in just 24 hours, 500 square miles of ocean have turned to this distinctive green color.
They replicate very, very fast. So you can have a plankton bloom that doubles over the course of a day and can cover hundreds or thousands of kilometers of the ocean surface.
It's the minerals from beneath the Earth's crust that have helped fuel this vast explosion of plankton, over 800,000 tons of living material. And that's only the beginning. This plankton is the base of the food chain for marine life. The bloom triggers one of the largest feeding frenzies on Earth. Trillions of anchovies and sardines feast on the tiny organisms. They, in turn, attract larger predators to one of the densest concentrations of marine life anywhere. Sharks converge, and even birds, flying above, dive down to join the feast. And up above, humans are here too, taking advantage of one of the world's most productive fishing grounds. The satellite data reveals similar upwellings all around the world, delivering nutrients, seen here in pink, into the surface waters. Each upwelling triggers a plankton bloom.
Phytoplankton provide that key link between this energy out here, the raw materials that this planet holds, and the food engine that allows life to flourish.
These vast green ribbons of plankton can cover as much as a fifth of the world's ocean surfaces. About 45 billion tons of biomass every year. The plankton are one link in a chain of life that begins deep beneath the seafloor.
The most important plant life on this planet are these microscopic little green plants that float in the ocean.
Plankton may be key to life, but they themselves don't live long. MODIS shows how, in just 72 hours, a bloom can rapidly weaken and fade. All the plankton that have not been eaten die and sink into the abyss. They take their precious minerals with them, all the way back to the ocean floor. Here they will remain for millennia, a thick carpeting of tiny carcasses half a mile deep. Some of the minerals may ultimately be recycled. Some may emerge through hydrothermal vents again, millions of years from now. But some plankton, through yet another extraordinary chain of events, will deliver their precious cargo of nutrients not just to life in the ocean, but also to life on land. Half a world away from the coast of Peru, where plankton bloom, lies the Sahara Desert in North Africa. The Sahara is enormous. It makes up a tenth of the African continent. It's one of the driest and dustiest places on Earth. Surprisingly, the remains of ancient plankton are here, hidden in this arid landscape. It is May, the hottest month of all. Camel herders travel through one of the most exposed regions of the Sahara, the Bodele Depression. 6,000 years ago, this was covered by the world's largest freshwater lake. The floor of the lake is covered with the ancient remains of plankton, called diatomite, laid down in a much earlier age, when an ocean covered the region. With its eye on the Earth from 400 miles above, NASA's Landsat 7 is one of the latest generation of satellites studying the composition of rocks that make up our planet. It sweeps the Bodele, producing these high-resolution pictures in multiple wavelengths of visible light. The white expanse is the diatomite on the bed of the lake.
The size of the lake is over 1,000 kilometers long and 600 kilometers wide. But with a satellite image, we can see the whole extent of the basin on a series of images and visualize that on a computer in a matter of minutes.
The satellite image analysis shows over 24,000 square miles of sediment, all of it diatomite.
We can map where the diatomite sediment is on the floor of the lake.
The diatomite from the plankton is a rich source of phosphorus, an element needed by all living things to produce energy. But for this nutrient to re-enter the chain of life, it must first embark on a long journey that can be seen from space. The journey begins here, on the ancient lakebed in the Sahara. The wind sweeps up a few flakes of diatomite into the air. The flakes fracture into a fine powder and are carried off by the wind. A dust storm builds. "22,000 miles above, the European weather satellite Meteosat 8 looks down from its geostationary orbit. It records a daily pulse of dust rising off the Bodele Depression. Here, it's visible as a whitish dust cloud lifting from the desert with clockwork regularity at noon each day.
Although the individual particles of dust are minute, they're like hundredths or thousandths of a millimeter in diameter, there are such vast clouds of this dust that you can see it on satellite images.
The dust cloud is over 100 stories high and 200 miles wide. From here, it will head west on an epic journey. Seen from space, the dust is blown across Africa. At the Atlantic coast, it's drawn up high into the sky. This simulation, based on satellite data, shows how prevailing winds carry the dust cloud west and south, 3,000 miles across the Atlantic. As much as 7,000 tons of dust are airborne at any one time. The destination is set by the winds, South America and the Amazon.
We're taking literally thousands of tons of this dust, which is containing phosphate, and exporting that from the Bodele. The wind is carrying it out across the Atlantic to fertilize the Amazon.
Here, in these clouds high above the rainforest, what was once living plankton reaches the end of its journey. The minerals in the dust, which include energy-giving phosphorus, dissolve into water droplets and fall to the Amazon in rain.
Areas like the Amazon jungle, although they appear very rich, the soils are actually very depleted. They've been leached. And one of the things that they're short on is phosphate.
Rain falls incessantly throughout the Amazon's wet season, delivering thousands of tons of phosphate into the forest below. It passes into the soil and the roots of the trees, nourishing the rainforest. The effect of all this natural fertilizer can be seen clearly from orbit. Terra is the twin of the Aqua satellite. It circles the Earth every 99 minutes, monitoring how fast vegetation is growing.
We can see all the green vegetation on Earth, wall to wall, every day, and it tells you almost everything you want to know about the state of life on Earth.
With its color scanner, Terra can see the effect of the Sahara dust on the Amazon at the end of the rainy season. It observes an increase in the distinctive green color of chlorophyll. Like the plankton blooms in the ocean, the forest is kicking into overdrive. Watered by rain and nourished by the minerals borne across the Atlantic by the dust cloud. For every leaf that exists now, 3 more will grow in a week. It's the culmination of a chain of events that began far back in time and halfway around the world.
Ancient sediments laid down by other organisms millions of years ago get eroded, make dust. The winds bring them across the Atlantic, fertilize the tropical forest in the Amazon.
The migration of Bodele dust to the Amazon is just one of many ways that vital minerals spread to living habitats all over the world. Every landscape has its own story and its own way of entering the chain of life.
The exchange of nutrients from the land is going on all over the globe every day.
And in certain areas, this is what accounts for the special productivity of the soil. The Great Plains of North America are rich in minerals eroded from the Rocky Mountains. These are vital ingredients for growing wheat and corn. In Bangladesh, the Ganges Delta is rich in iron, washed down from the Himalayas in river sediments, ideal for growing rice. The hidden transport of minerals creates fertile soils that enable plants to thrive. These minerals are the basis of the food chain for all life on land, including us.
All of this reminds you how interconnected the Earth system is. That no living thing lives in isolation from processes that may happen a long way away in both space and time from itself.
Satellites provide a vivid new perspective on the links between land, sea, air, and life. This new perspective helps us see how the natural forces of our planet fit together. And that includes the atmosphere and something as basic as the air we breathe.